solve the difference equation yn plus 2 plus 2yn plus 1 plus yn equal to n, given that initial conditions are y0 equal to y1 is equal to 0. So given the equation, difference equation is yn plus 2 plus 2yn plus 1 plus yn is equal to n. Now taking z transformation on both sides, so z of yn plus 2 plus 2 into zy n plus 1 plus z yn is equal to zn. So we know the formulas for zyn plus 2 and zyn plus 1. So substituting that one, so z square into f of z minus y0 minus y1 by z plus 2z into f of z minus y0 plus z of yn is nothing but f of z, so f of z which is equal to z of y. We know z of n which is equal to z by z minus 1 by whole square. So replacing left hand side becomes z by z minus 1 by whole square. Now the right hand side multiplying z square with each terms, right? So z square into f of z minus z square into y0 minus z into y1, because z square into y1 by z square and z in denominator get cancelled. So remaining you will have z into y1. Now second term multiplying with 2z with each term, so 2z into f of z minus 2z into y0 plus f of z which is equal to z by z minus 1 by whole square. So now we are using the initial conditions. So initial conditions y0 and y1 is equal to 0. Substituting these values, so z square f of z minus z square into 0, 0 second term, third term z into y1, y1 is 0, so z into 0, 0 third term, and fourth term 2z into f of z minus 2z into y0 is 0, so y0 into 0, so y0 0, so minus 2z into 0, 0. Then last term f of z which is equal to z by z minus 1 by whole square. Grouping this, f of z is common, the three terms, so taking outside, so z square plus 2z plus 1 into f of z which is equal to z by z minus 1 by whole square. Therefore f of z which is equal to, taking that z square plus 2z plus 1 the numerator left hand side to the denominator right hand side, so f of z which is equal to z by z minus 1 by whole square into z square plus 2z plus 1, right? That is f of z. That is f of z is nothing but z of y of n which is equal to z by z minus 1 the whole square plus z plus 1 the whole square. So group, right? Now to find yn we are using residue method. So multiply both side by z power n minus 1. So f of z into z power n minus 1 which is equal to z power n minus 1 into z by z minus 1 square plus z plus 1 square. So grouping z power n minus 1 into z. So you will get z power n because z power n minus 1 plus 1. So minus 1 plus 1 get cancelled. So in numerator you will get z power n by z minus 1 square into z plus 1 square. Now we have to find the pole of f of z into z power n minus 1. So that is nothing but taking the denominator the right hand side equal to 0. So z minus 1 square equal to 0 and z plus 1 square equal to 0, right? So z minus 1 square equal to 0 means z is equal to 1. It's a pole of order 2. And z plus 1 whole square equal to 0 means z is equal to minus 1. It is also a pole of order 2. Now we have to find the residue using the residue formula, right? First R1, taking a is equal to 1 in this formula. Residue f of z into z power n minus 1 z equal to a is equal to, because this is order 2, so we are using the formula 1 by 1 factorial limit z tends to a d by dz z minus a square f of z into z power n minus 1. So taking first pole a is equal to 1. So R1 which is equal to limit z tends to 1 d by dz of z minus 1 square z power n by z minus 1 square into z plus 1 square. z minus 1 square into z minus 1 square in the denominator get cancel. So remaining you will get limit dz tends to 1 d by dz z power n by z plus 1 the whole square. Now we are taking differentiation with respect to z of z power n by z plus 1 the whole square. So we are using u by v formula. So u by v, derivative of u by v is equal to v square in denominator, numerator v into derivative of u minus u into derivative of v. Here v is equal to z plus 1 the whole square and u is equal to z power n. So limit z tends to 1, denominator square. So z plus 1 the whole square, the whole square. So 2 into 2, 4. So in denominator you will get z plus 1 power 4. Numerator, keeping z plus 1 the whole square, v into derivative of u. That is u is nothing but z power n. Derivative of z power n, n into z power n minus 1 minus. Keeping u is z power n. So z power n into derivative of the denominator, derivative of z plus 1 the whole square, which is equal to 2 into z plus 1 into derivative of z 1. So it is equal to, so grouping this and substituting the limit value z is equal to 1. So 1 plus 1 the whole square, n into 1 power n minus 1 minus 1 power n, 2 into 1 plus 1 into 1 divided by 1 plus 1 power 4. So 1 plus 1 square, so you will get 4. So grouping that, 4n minus 4 by 16, taking 4 outside, so you will get 4 into n minus 1 by 16, so n minus 1 by 4, right? So R1 which is equal to 1 by 4 into n minus 1. Now we are going to find R2, taking a is equal to minus 1, so proceeding like above. So R2 which is equal to limit z tends to minus 1, d by dz, z plus 1 the whole square, z power n by z minus 1 the whole square into z plus 1 the whole square. Cancelling z plus 1 square in the numerator and denominator. So you will get limit z tends to minus 1, d by dz of z power n by z minus 1 the whole square. Now again we are doing the derivation of z power n by z minus 1 the whole square by using the formula derivative of u by v. So limit z tends to minus 1, keeping z minus 1 the whole square and derivative of z power n, n into z power n minus 1 minus keeping z power n and derivative of z minus 1 the whole square. So 2 into z minus 1 into 1 in the denominator, z minus 1 square the square. So z minus 1 power 4. So substituting the limit, z instead of z you put minus 1. Minus 1 minus 1 square, n into minus 1 power n minus 1 minus minus 1 power n, 2 into minus 1 into 1 by minus 1 power 4. That is 4 power n minus 1 power n minus 1 plus minus 1 power n into 4, right? Because you will get minus 1 in the second term, minus 1 minus 2, right? Minus 2 into 2 minus 4, minus 4 into minus plus, that is why. So in the second term plus minus 1 power n into 4 by 16. Taking 4 outside, so common, that is, so n into minus 1 power n minus 1 plus minus 1 power n by 16. 4 and 16 get cancelled, so 1 by 4 into n into minus 1 power n minus 1 plus minus 1 power n. So both we know the both residues R1 and R2. So by residue method, y1, the solution y1 which is equal to sum of the residues, that is R1 plus R2. So summing up, so R1 1 by 4 into n minus 1 plus 1 by 4 n into minus 1 power n minus 1 plus minus 1 power n minus 1. Right? So that is the solution of the given difference.